So we move over now to the measurement of damping. So here we have a damp harmonic motion presented by this uh, wave. Okay, so this is now your uh, vibration representation, which is damp harmonic. And to get the damping property of a system, all we have to do is to get or to measure the value of the successive amplitudes of the same sign. So this is y1, this must be y3. So if this is y2, this must be y4. Okay, so this is a different sign, so we do not consider uh, this as successive amplitudes of the same sign. So if we let delta now to be the ratio of two successive amplitudes of the same sign, we can readily get your logarithmic decrement by simply taking the solution for y I and yi plus 2. Okay, so the solution may be represented by an exponential function in the form of y is equal to a e raised to a negative kt. Okay, or we can make use of a trigonometric function cosine uh, kt plus sine b sine k2. Okay, so here k is actually equal to lambda omega. So it's a combination of your damping ratio and natural frequency. So for the logarithmic decrement, so this is a logarithmic decrement, your delta, small delta, is simply the natural logarithm of big delta. So defining it as so, we take the logarithm of e to the lambda omega td, so we simply derive this equation. And taking note that if we have here an exponent, we can simply put it down there. Therefore, delta will simply be equal to uh, lambda omega d damp times long or ln of e. So this is equivalent to 1. Therefore, your delta is lambda omega t. Okay, we know that the period is actually the reciprocal of frequency in cycles per second. So simply this will be 2 pi over omega damp, because that's damp. So this must be the same. Okay, and if we substitute it there, so we get lambda omega 2 pi over omega damp. So this is now your equation for the logarithmic decrement. But we now insert another formula for omega d. So the damp frequency is simply the natural frequency multiplied by the square root of 1 minus lambda square. Okay, so take note that lambda is actually your uh, critical value of your damping coefficient. So C all over CR. Okay, so this is more or less always less than 1.0, such that if we substitute it here, we simply get this formula here. Okay, so delta is equal to 2 pi lambda all over the square root of 1 minus lambda squared. So your omega and omega there will cancel out. Okay, note that for small damping, your delta may be logarithmic decrement. Delta may be simplified by assuming this to be equivalent to 1.0.